Welcome today to the lesson on least common multiple, otherwise known as the LCM. First, we'll talk about the steps for finding the least common multiple. It's very similar to finding the greatest common factor with a slight difference. Step 1. Find the prime factorization of each number, just like we do for GCF. The next step, you have to organize and circle similar factors, just like the GCF. But this time, it doesn't have to be all three if you have three numbers. You can still just circle two at a time. The next thing we're going to do is we're going to multiply the circled and leftover primes. Let me demonstrate using two smaller numbers, and then we'll use some examples with bigger numbers. Some of the uses for the LCM include finding a common denominator for two fractions when they don't have one. Let's start with our example, this one right here. Find the LCM for each set of numbers. The first set of numbers we're going to do are 12 and 15. Let's write out the prime factorization for 12 and 15. 12 and 15. We've done these numbers a couple of times in class and on the homework, so this shouldn't take too long. I'll do factor trees for the first example. So for 12, we have 2 times 6, 2 is prime, and then for 6 we have 2 times 3, 2 and 3 are both prime. For 15, it's even easier because 15 is only 3 times 5. Those are both prime. So let's list the prime factors for each one. So 12 is 2, 2, 3. And we kind of want to line up the numbers that are similar. So on 15, I'm going to write 3 and 5 so they're next to each other. All right, so what we're going to do is we're going to go along each vertical column and circle anything that they have in common. So this 2 right here, this one right here, doesn't have anything in common. This one doesn't have anything in common either. But these 3s they have in common, and the 5 is not. So the 3s are the what's in common. We're only going to count that once. So when we do the least common multiple, we're going to write the 2, the other 2, and then only one of the 3s and a 5. And then to find the least common multiple, all we have to do is multiply those together. So 2 times 2 is 4. 4 times 3 is 12. 12 times 5 equals 60. So our LCM is 60. And we are done with this example. So a quick recap on what we did. We found the prime factorization for 12 and 15. We found the numbers that they had in common, and we had all these other leftover numbers that they didn't have in common, and we just take each one and we multiply all those together. Notice that with the 3s, they were a set, but we only counted them once because we circled them together because they had those in common. Okay, let's look at the example 24 and 32. So 24 and 32, I'll go ahead and write out the prime factorizations for those. So I'm going to write down 24, 32. I'll pause for a second and let you guys write the prime factorizations for 24 and 32. Do 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 do. All right, hopefully you got the prime factorization of 24 to be 2 times 2 times 2 times 3. And 32 is just 5 2s. 1, 2, 3, 4, 5. Now, on this example, you'll notice that we have more factors in common. So we have a 2, another set of 2s, another set of 2s, and then that's it that they have in common. So we have these 2s here left over and this 3. So everything that I have circled gets counted once. So when I go to do the LCM, my least common multiple, I'm going to take this 2, I'm going to take this 2, I'm going to take this pair of 2's, and then each of these 2's that are separate, and the 1, 3, and I list all those out. Now, as I go, I'm going to kind of multiply these together. So 2 times 2 is 4. 4 times 2 here is 8. 8 times 2 here is 16. So this is up to here. 16 times 2 is 32. And then we have to multiply that by 3. So 32 times 3 equals 6. And then 3 times 3 is 9, so 96. So there's our LCM, 96. And there's our second example. 96 is the LCM. Let's pause briefly to make sure everyone is able to write this down. This last example is going to be a little more complicated because I added in some x's and y's, but that really doesn't change much. So let's go ahead and do this. First thing I'm going to do is I'm going to write out each of my terms. So 12xy squared. Then I have 30xy and 18x squared. Then I'm going to write out the prime factorizations for each number. We've done 12 above, so that one should be pretty easy. It's 2 times 2 times 3. And then we have x and y squared, so x with 2 y's. 30 is basically 2 times 15, and 15 is 3 times 5. So I kind of want to make sure that these line up. So let me rewrite that a little bit. And put the 5 over here. And then we have an x and a y, so I want to kind of make those line up. And the last one we have is 18. So 18 is 2 and 9, so that's 2, 3, 3, and then we have 2 x's. All right, so let's take a look at each of these. So what we're going to do is we're going to circle the ones that they have in common. So in the first 3, it's all 3 of them have a 2. All 3 of them have a 3. Now, we have this 2 left over, this 3 left over, this 5 left over. All 3 of them have an x, and only 2 of them have a y, but we're going to circle those. And then we have an x and a y left over. So we're going to take each one of those, and we're going to multiply it all together. So let's scroll down here a little bit. Okay, so let's write out all the numbers. We've got a 2 right here, this 3 sets of 2's. And then we have a 2 up here, so that's a 2. And we've got the 3's here. All these 3's count as 1. Then we have this solo 3 here. We have a solo 5 here. We have a three x's in together. And then we have an x over here by itself. And then we have a set of y's, so that's a y. And then we have this other y by itself. So what I did was I looked at the 2's that were in common, wrote that. This 2 that's by itself, there's that. A 3, and then a 3 by itself. The 5 is all by itself. Set of x's, but only 2 y's, and that's okay. Oops, I forgot about the other x, so I put that. And then the 2 y's are okay, and then the 1 y by itself. So I got to multiply all of this together. So let's pause while you guys multiply these together. So hopefully, after you multiplied 2 and 2 and 3 and 3 and 5 together, you got 180. And then you put the x's together to get x squared and the y's together to get y squared. So your LCM is 180x squared y squared. And that's an example with 3. And again, noting that when you have 3 numbers, it can be all 3 or only 2 of them at a time. That's one of the major differences between the least common multiple, LCM, and GCF. With a GCF, you have to circle all or nothing. With an LCM, you can do a pair, and then it's okay to just do 2 of them at a time, as long as they don't have all 3. So just do 2 and count that. Okay, if you have any other questions, please ask for another example from your teacher.